Hey dudes, sorry I couldn't be here with you today. We're looking at 2-8 graphing lines from equations. Before we go into it, I'd like you to try a little warm-up with me. We're trying to solve the inequality for x. It's just a blast from the past, see how you can do with it. Pause me until you got it, and then see if you got it right. Alright, so if we're trying to solve for x, it's just like solving an equation. Let's undo all the steps. So let's subtract 5, those cancel out. This ends up being negative 21 and negative 3x, and we don't have to change the sign or anything because we're subtracting, but let's keep going with it. Let's divide by negative 3, divide by negative 3. Since we divided by a negative, those cancel out. We're just left with x, which is nice, and this is 7, positive 7, which is nice, but since we divided by a negative, we got to remember to flip that sign, and so you should end up with that. Cool? All right. I want you to understand like slope-intercept and standard form, be able to convert between them, and check if a point is on a line when you walk out of here. So there's two types of major types of equalities, equations that we talk about showing the equation of a line. And one of those is slope-intercept form, or British call it gradient, but I use slope-intercept. So this is this type. And another way to show it is in general form, that type, like that. And so they have a little bit of a difference, and they're useful in different ways, but just I want you to be able to pick which one is which. Slope-intercept has the slope, the x and the constant, right? The stuff with the x's and the stuff with just the regular numbers are on one side, and y is by itself with no value over here, right? The general form has the x's and y's on the same side, the constant on the opposite side, and the coefficients, the numbers in front of x and y, are just regular they're whole numbers, right? They're not fractions. So that's the difference between the two. So even if you wrote like 15 equals 2x minus 4y, that's still general form because the x's and y's are on one side and the regular numbers, the constant, is on the opposite side. Cool. Okay. So slope-intercept form looks like this. And the major parts are this is the slope, and this piece is the y-intercept, like where the line hits the axis. You could kind of think about it like this. You start at the c value, and every time you go over 1x, you change like this. So, for example, if we're using 2x plus 1, and we're trying to graph it, it would start here at 1 on the y value, and every time you go over 1 unit, you would change like this, right? Change in the y by 2. So you go up 2 over 1. It's the slope. This is the slope. Rise 2, run 1. Rise 2, run 1. There's your next point. Rise 2, run 1. There's your next point. Rise 2, run 1. There's your next point. So that's kind of how we use them. Now we're going to do a lot more work trying to figure out how to graph them given the equation, or with the equation given the graph, etc., etc., etc. So let's try it out. Draw the graph of this. Negative 3/4 x plus 5. Well, I would walk it like this. I know that this is y equals mx plus c. The c value is where you start on the y-axis. So that would start here, right, at 5. And then to get any other point on the graph, you'd follow this slope. And so the slope is negative 3 over 4. So from there, I would go down 3, 1, 2, 3, and over 4, 1, 2, 3, 4, and make another dot. And then draw your line between the two dots, if you could actually hit it. Cool. So that's negative 3/4. And you can do this with all sorts of equations in the same way. If you had, I don't know, y equals negative 1/2 x plus 6, you'd start the graph up at 6, 1, 2, 3, 4, 5, 6 here, and then you'd go down 1 and over 2, down 1, over 1, 2 to the next point, and then you'd connect your dots like that. Cool. That works when this is slope-intercept form. If it's not slope-intercept form, it might be in standard form, and standard form is useful for a specific reason. I know wherever this line hits the x-axis, if it's here, it's 1, 2, 3, 4 over and 0 up, right? If it hits over here, it's 1 over and 0 up. If it hits over here, I'm thinking about like where it goes through, where it like runs through like that. Wherever this line hits, if it's there, if it's there, if it's here, it's like negative 1 over and 0 up still, right? So I'm not exactly sure, you know, where this x value is, but I know that the y value is 0. So what we can do is plug in 0 for that y value, right, and see what the x value is. So this should be 4x minus 3 times 0 equals 12. This is 0. So you end up with 4x equals 12. And you end up with x is 3. Right? And so that means on this line, the green line we're looking for hits at 3, just like we sort of hoped. Yeah. So now I plot a point like this, and then we do the same, play the same game with the y value, right? And so with the y value, I know that this point, if the line hits here, it's 0 for x, but something for y. If it hits here, it's 0 for x, but something for y, right? Here it would be like negative 2. I don't really know what those are, but I know in all of those places the x value is 0 because it's right on that line. So therefore, we can do something like this. We can plug in the x value. We can say, hey, let's let this be 0. And so you can say, if this is 0, you get 4 times 0 minus 3y equals 12. And you can solve for this y. 4 times 0 is 0. You get negative 3y equals 12. You divide by negative 3, you get y as negative 4. You put a dot there. Right? There's a dot there, there's a dot there. 2 dots is all you need to make a line. You run your line. Hopefully you actually hit it instead of Mr. G. And your line looks like that. Ba-boom. Cool. Let me give you another one, just for example. If you were graphing something like 2x plus 4y equals 8, I'd say I know on this x-axis, wherever this hits the x-axis, the y value is 0. It's not up, it's not down. So let's put in 0 for y and solve for x. This would be 2x plus 4 times 0 is 0, so equals 8. You'd solve for x, you'd say divide by 2, so x is 4. So this hits at the x-axis at 4. And then you'd play the same game with this. You'd say wherever it hits here on the y, I know the x is 0. So put 0 in for the x. You'd get 2 times 0 plus 4y equals 8. And this is 0, so you divide both sides by 4, and you'd get y is 2. So 1, 2, so up there, right? And then you draw your line. Cool.